This is Chi-squared, page 1. Number 1, Misty was interested to find out whether preference for car color was dependent on gender. So you can see in the table that across the top it's got car color and across the side it's got gender. She asked 80 of her friends and the results are shown below in the table. Since she asked 80 of her friends, the grand total is 80. And along the bottom and along the sides here, they were nice and they totaled it up for us. So even though that not all problems are going to have the totals, you might have to total it up yourself. In this problem, they're saying show that the expected number of males who prefer black cars is 10.45, and show that the expected number of females who prefer white cars is 9.45. Now, if they just ask us to calculate the expected frequencies for the categories, we could do that with the calculator, but they're asking us to show that the expected number is a certain number. So that means we need to actually do the calculation ourselves. So the calculation to find out the expected frequency of any category is you multiply two fractions together and you multiply that fraction that you get by the total number of people, 80. So, for example, if they want to know males who prefer black cars, then you would say, okay, males would be this row here, and then black cars would be this row here, so that would be the quantity that would go right there. And it's not going to be 14 because 14 is the observed value. What we're going to do is we're going to figure out what this number should be given the proportions that the subtotals and the total give us. So 14 should be proportional to the fractions 22 over 80, which is the fraction related to black cars. 22 out of 80 are black cars. And then we multiply that times 38 over 80, which is the proportion of males. And then we multiply this combined fraction times 80, which will give us the number of males who like black cars that we would expect to see. And to see exactly what that would be, we would put these two fractions into the calculator. So the first fraction is 22 divided by 80. And the second fraction is 38 divided by 80. And the last number is 80. And it turns out that the expected frequency is 10.45, like they said. So we've just demonstrated that by showing that we multiply subtotal 22 divided by 80 times subtotal 38 divided by 80 and multiply that times 80. That gives us the expected number of males who like black cars. You can see that 14 is the observed value, what we really saw in our survey. And so that means that there are slightly more people than what we would expect. We would expect 10.45 people. We found 14 people. Then it asks us to show that the expected number of females who prefer white cars is 9.45. We're going to do something similar, except we're going to use the white row, which would be a subtotal of 18, and females, which would be a subtotal of 45. So that would be 18 divided by 80 times 42 divided by 80 times 80 equals, so that would be 18 times 42 times 80 in the numerator, and then we would divide by 80, divide by 80. Now, unless you really know what you're doing with PEMDAS, I wouldn't do it like that. I would do it kind of like I did above, or maybe you could use the math button, and then you could go to number, and go to n over d, and then you could put everything on top that goes on top, 18 times 42 times 80, and on the bottom you put 80 times 80. See, that's maybe the easiest way to do it. And that gives us 180 divided by 20, and if we want to see the decimal version of that, we go into math, and then we put decimal, enter, 9.45. Okay, so we have shown that the number of females who prefer white cars is 9.45. The observed value is actually 12, which is slightly higher than that, so we see more females who like white cars than what we expect. And finally it says find the chi-squared value. The way you find the chi-squared value, of course, is to put it into the calculator, and we're going to do a problem later where we talk about how to do this in your IA outside the calculator. But first we're going to go to matrix, second matrix, and then we're going to put it into matrix A, the data. And when we put in our data, remember we're only putting in the data itself, not the subtotals. So we're going to have a 2 by 4 matrix, and we'll put 6, 14, 10, 8 across the top and 12, 8, 9, 13 across the bottom. And I'll do this offline so that I don't bore you. Build in the numbers by pressing the number keypad and by moving around with the arrows. And then I exit here by going to second quit. So I've put everything into matrix A, and then I'm going to do second, I'm just going to do stat, tests, because I'm going to go the chi-squared test. I'm going to go from the bottom. It's a little bit closer if I go from the bottom. And then I put observed matrix A, which I've just filled in, expected matrix B, which I have not filled in, but it's going to fill in all the expected values into B, and then it gives me this information here that the chi-squared value is 4.69, which is what they asked for. So I'm just going to write that down here. The chi-squared value is 4.69. Give me 3 significant figures usually. And that's all they asked for. Okay? Let's go on to number 2. Max was watching people coming out of a takeaway coffee shop. He was noting down the gender and whether they had bought a small, medium, or large coffee. The results were as follows. So again, they have kindly given us the totals here, which is not actually a part of the contingency matrix, which is what they call this table. Show that the expected number of males who buy a small coffee is 16.7. So expected number of males, which is 54 out of 110, who buy a small coffee, which is 34 out of 110, show that that total gives us 16.7. So we would do a multiplication of 54 over 120 times 34 over 110 times 110. And one trick you can do to make this a little bit easier is you can cancel out one pair of 110s. If you're pretty good at algebra, you can do that and probably save a little bit of time. But if you are not that strong in algebra, go ahead and keep everything in there and do math, number, n over d, and then we'll do the multiplication, which is 54 times 34 times 110 on top. And then we do 110 times 110 on the bottom. And that would give us 918 divided by 55, but we would like to know that in fraction or in decimal terms, so we change it to a decimal by going to math decimal. It's 16.7, so yes, it is 16.7. Show that the expected number of females who buy a large coffee is 23.4. So females who buy a large coffee, females would be 56 over 110. Large coffee would be 46 over 110, so that would be 56 over 110 times 46 over 110 times 110, and that would give us, I'm going to go into math again, number, and then I go up, n over d. I'm going to put 56 times 46 times 110. And on the bottom, I'm going to put 110, times 110. And it's going to give me a fraction, so I'm going to go into math decimal. So I get 23.4, which is what we wanted also. Okay, so we've shown that too. Finally, find the chi-squared value. So as I said before, the way you find the chi-squared value is you input this matrix into matrix A, and the way you do that is you go into second matrix edit, and then we're going to go into matrix A, and our matrix is actually 2 by 3, 2 rows by 3 columns. So we put 2 by 3 here, and then it changes the matrix to 2 by 3, and then we're just going to input these 6 numbers. I'm going to do that offline so I don't bore you. Input, now I just run stat tests, go up to the next page to the chi-squared test. My observed is A because that's where I put my data. B is where they're going to put the expected frequencies. And I do calculate, and my chi-squared value is 5.21. By the way, the expected values are put into matrix B, and if I want to print out matrix B, I do second quit. I go into second matrix, and I just go into, I just say, oh, matrix B, give me matrix B. And it prints out matrix B for me. Okay? Let's go into the next problem then, number 3. Brenda works in a pet shop. She watches the rabbits, guinea pigs, and hamsters to see if they eat lettuce or carrots first. Here are her results. Show that the expected number of rabbits who eat carrots first is 26.9. So I'm just going to write out the equations here. I'm not going to actually do the multiplications because you've already seen how to do that. So carrots, rabbits who eat carrots first. Oh, look at that. We need to do the totals though because they didn't give us the totals. So what we do is we add up the columns. So 16 plus 34 is 50. 16 plus 18 is 34. And 28 plus 18 is, that would be like 50, be 40 something, 46. Okay, and then we're going to add up the rows. And we'll do that in this direction. So it would be 16 plus 16 plus 28, which would be 32 plus 28, which would be 60. And then we're going to do the second row. 18 plus 18 is 36. 36 plus 34 is 70. And then just as a final check, we'll add these two. We get 130. And then we add these 3, and we get 130 also. So it looks like we did it correctly. And we'll put 130 here for the grand total. And now we're going to see, okay, for rabbits who eat carrots first, it would be rabbits 50 over 130 and carrots 70 over 130. Okay, so we'll put 50 over 130 times 70 over 130 times 130. So that would be part A. Okay, that should give us 26.9. Next thing we're going to do is we're going to do expected number of hamsters who eat lettuce first. So for that, we're going to find hamsters, which would be 46 over 130, and lettuce, which would be 60 over 130. So we'll do 46 over 130 times 60 over 130 times 130. Okay, so that would be 21.2. Finally, it says to find the chi-squared value. Again, the way you find the chi-squared value is you go to second matrix, and you put in this matrix. You put in the 2 by 3 matrix here without the totals. I'm going to put it into A, so I'm going to go to second matrix, edit. Sometimes I accidentally go into names. It's the wrong place. And I'm going to input these numbers here, which I'll do offline so that I don't bore you. So I just put everything in there, and then I'll do stat test chi-squared. put AB for observed and expected, and I calculate, and it gives me a chi-squared value of 8.05. Okay, and then I move on to number 4. Again, for number 4, they did not do the totals, and since they want the expected number of males who come by bicycle and the expected number of females who come by car, and they want to show it to it, they want us to demonstrate how to calculate it, we do need to do the subtotals. So 12 plus 21 is 33. You could do these with a calculator if you need to. Bus would be 25. Bicycle would be 43. Walking would be 19. The top would be 20, 48, 60 for the top row. The bottom row would be 21 plus 13 is 34, plus 15 is 49, plus 11 is 60. So it looks like adding up the two 60s, you get 120. If you add up across the bottom, 58 plus 40, it's like 98, 101. Yeah, you get 120 both directions, so that checks out. Then it says, okay, show that the expected number of males who come by bicycle is 21.5. So males who come by bicycle should be 43 divided by 120 times 60 divided by 120 times 120. So that should give you 21.5. And then females who come by car would be 60 over 120 divided by 33 divided by 120. So if we wrote that out, it would be 33 over 120 times 60 over 120 times 120. That should give you 16.5. Then we're going to find the chi-squared value. The way we find the chi-squared value is we do second matrix, and we go into matrix. Oops, we always need to do edit. I always forget to do edit. And this is a 2 by 4 matrix, so we change it to 2 by 4. And then we fill in these numbers here, which I'll do offline so I don't bore you. I typed in my 2 by 4 matrix without subtotals and totals, and then I just do stat test, chi-squared test, the C option, AB for observed and expected, and I do the calculate, and my chi-squared value is 6.898, which rounds up to 6.90. Okay. Then I go to the last problem on the page, which is that Pippa sends out a questionnaire to 50 of her classmates asking what their favorite sport is. She wants to conduct a chi-squared test at the 10% significance level to find out whether favorite sport is independent of gender. The results are as follows. So the first thing, this is almost like an IA here, okay? Now remember, the 10% significance level is just to tell us what the critical value is, but in an IB exam, they're going to tell you what the 10% significance level corresponds to. So you're going to compare that later to the p-value when you need to. Okay. So first of all, we don't need to use that for anything. Now what we're going to do is we're going to total up for males and for females the sports that they do, and we're going to put male and female here, and we're going to put cycling, basketball, and football. So basketball, cycling, and football. So we do that by counting up the number of cycling for males, for example. So 1, 2, 3, 4, 5, 6, 7. So there's 7 males who like cycling. And then for males who like basketball, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 males who like basketball. And then, let's see, let's do football. So males who like football, there's 1, 2, 3, 4, 5, 6. There's 6 who like football. Okay, now we're going to do females. We have to be careful because there are females here and up here. Okay, so first let's do cycling because we have the blue pen out. So we'll do 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 females who like cycling. Let's do basketball. 1, 2, 3, 4, 5, 6, 7, 8 who like basketball. And then finally football. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 who like football. And then we add some of these up. So 18 plus 16 plus 16. And across the top we get 23. Across the bottom we get 27. So that is a total of 50, which is what they said it would be. So that is perfect. Okay. Then it says to set up a contingency table to display the results, and we just did that. Okay, this is the contingency table, which has the observed frequencies, and in this case we even put the totals. Write down the null and alternative hypothesis. So basically the null hypothesis is written like this, and the null hypothesis is that gender and sport preference are independent. So basically, whenever you write a null hypothesis, you say something and something are independent, okay? And the alternative hypothesis, which is written H subscript 1, is basically the same thing, except you say are not independent. So gender and sport preference are not independent. Okay? So those are the two hypotheses. And then for C, we say write down the number of degrees of freedom. The way we do that is we count up in this contingency matrix here, which has 6 numbers in it. We calculate by taking the number of rows and the number of columns, and we multiply them together, except instead of multiplying the number of rows and columns, we subtract 1 from the number of rows and subtract 1 from the number of columns. So we basically get 3 minus 1 times 2 minus 1, because the number of rows is 2, the number of columns is 3, so we subtract 1 from each of those. So it's 2 times 1. So the degrees of freedom is 2. Find the chi-squared and the p-value. Now the way we do that is what we just did before. We go into second matrix, into matrix A, we edit matrix A, we type in the values that are highlighted in yellow here, only the matrix itself, not the totals, and then we do the stat tests, and then we go to chi-squared test, and then we put A and B into observed and expected, and we press calculate, and then now we're going to have, let me get a red pen. We're going to write down the chi-squared value as 1.16, and the p-value is 0.5599, which would rounds up to 0.560 if we put 3 significant figures. Check that the expected values are greater than 5. The way we do that is we look at the expected value matrix, which we can find in second matrix, edit B. And B is already filled in, and if we look here, all the values, 8.28, 9.72, 7.36, 8.64, etc., are all above 5. So yes, they are. Okay? And then it says the critical value is 4.605, and we're going to compare our chi-squared value to that, And it turns out that our chi-squared value, which is 1.16, is less than the critical value, which is 4.605. So if the chi-squared value is less than the critical value, then we should accept the null hypothesis. So now if the opposite is true, the chi-squared value is greater than the critical value, then we reject the null hypothesis. That kind of makes sense because chi-squared is based on how divergent this data is, how different this data is from the expected value. So if the data is much different than the expected value, then you're saying that the null hypothesis is not true, that the assumption that everything is independent is not true. Now it says to comment on whether the p-value supports this conclusion. First thing is we go back and look at the p-value, which is 0.560, and now we're going to compare the p-value with the significance level, which is written right here, the 10% significance level. I said that we were going to come back to that. The significance level of 10% is represented in a decimal as 0.10. 0.560 p-value is greater than the 0.10 significance level, so we accept the null hypothesis. It leads us to the same conclusion. Okay, so basically if the chi-squared value is small and the p-value is large, then we accept the null hypothesis. Okay.